Okay, let's complete the implementation of this attention decoder. But before we start, I forgot to mention the generate method. If you haven't finished implementing this generate method, stop this video and finish implementing this generate method, okay? All right, let's implement forward first. We first need to get the last hidden state of the encoder. Why do we need to do this? Because we need to set the initial hidden state of the LSTM as the last hidden state of the encoder, like this. And we first go through the embedding layer, and decoding hidden states are gonna be passing through this LSTM layer. And we calculate the attention or the context vectors because this axis means the ground truth sequences. Therefore, we can calculate the hidden states at the same time. However, this might not be possible in the case of inference. Then concatenate the context vector and the decoding hidden states along the axis 2 and calculate score using our affine layer. All right, and we return score. And how do you calculate backward? You go in the reverse order. So we go through affine first. And we need to divide this D out into two parts because the first half should go to these context vectors, and the last half should go through this LSTM, okay? So that's why we need to divide H2 by 2. So up to H, it goes through context vectors, and the last part goes to decoding hidden layers. And because decoding hidden states goes through attention weights as well, and when we calculate backward, we receive another great upstream gradient another upstream gradient flow for decoding hidden states like this. Like this. And then we pass through LSTM backward. And because the last hidden state of the encoders was set as the initial hidden state of the decoder, you need to think about it as well, like this. And we go through the embedding layer, and then we return the encoding hidden states like this. And how do you implement this generate method? pretty simple. Sample and sample ID as start ID. And as usual, we retrieve the last hidden state of the encoder and set this as LSTM's initial hidden state, like this. And turn this sample ID as a tensor and go through the embedding layer first. So in this case, we are following what we've done in the slides. Sample one output, and then feed that output into next time steps input and get another output. So we are using for loop here. Take the context vector. And concatenate context and decoding hidden state. Calculate score. Get sample ID, calling arg max. Okay, like this. This is how we implement attention sequence to sequence. And for training, you can basically use the same training code we've implemented here. You can just change a model from picky sequence to attention sequence to sequence. Play around with this training code and try to get this graph, okay? All right, let's call it a day.